Good morning, I'm Josep. I study cross-platform development on Ilerna, and today I will talk about version control and collaborative development in open source projects. Uh, First of all, a little introduction because in modern software, development collaboration is not optional, it's essential. So open source projects involve developers from different countries, time zones, and backgrounds working together on the same code base. So this presentation explains how version control systems, especially Git, make that collaboration possible. So here is the structure of today's presentation. We will cover why coordination is necessary, what version control systems are, a decentralized against the distributed systems, Git as the industry standard, the core Git concepts, collaborative platform and pull requests, the standard open source workflow, the governance roles and challenge, and finally the future of collaboration. So, to understand why version control is so important, we need to think about how software development has changed over time. In the early days of computing, software was often written by a single programmer or a very small team, usually working in the same physical location. Coordination was relatively simple. You talk to the person next to you, you share the files manually, and the changes were limited. But today, the situation is completely different. Modern software projects are massive, complex, and global. Hundreds or even thousands of developers may be working on the same code base at the same time. These developers are often distributed across different countries, time zones, and cultures. Many of them might never meet in person, yet they collaborate daily on shared software. This is especially true in open source projects, where contributors are volunteers or professionals from around the world. Anyone can propose changes, fix bugs, or add new features. While this openness is a huge strength, it also introduces a major challenge: coordination. Without a proper coordination tools, collaborative development would quickly turn into chaos. Developers would override each other's changes, bugs would be hard to trace, and it will be nearly impossible to know which version of the code is stable. Version control systems exist precisely to solve these problems. They provide structure, order, and reliability in an otherwise very complex collaborative environment. So, let's define some version control systems. So, what exactly is a version control system? A version control system often abbreviates as IFCS is a tool that records changes made to files over time instead of simply storing the latest version of a file. It keeps a complete history of file modification. Each change is saved as a new version, along with important metadata such as who made the change, when it was made, and what exactly it was modified. This historical record is extremely valuable. First, it allows developers to revert to previous versions of the project if a bug is introduced or a feature breaks existing functionality. The team can easily go back to a known stable state. The second thing is that version control systems enable parallel development. Multiple developers can work on the same project at the same time without interfering with each other. Each contributor can make changes independently, and those changes can later be combined in a controlled way. And the third version control provides full traceability. Teams can understand how the project evolved over time, why certain decisions were made, and which changes introduced specific features or bugs. This is essential not only for development, but also for debugging, auditing, and long-term maintenance. In short, version control systems are not just technical tools, they are fundamental collaboration mechanisms that makes modern software development possible. So let's talk about the centralized against the distributed system, because version control systems can be broadly divided into two categories: the centralized system and the distributed system. In a centralized version control system, there is a single central server that stores the entire history of the project. Developers check out files from the server, make changes, and then commit those changes back to the central repository. An example of this type system is Subversion, also known as SVN. Centralized systems are relatively simple to understand, but they have important limitations because all history is stored on a single server. Developers depend heavily on that server being available, because if the server goes down, development can be severely disrupted. In addition, working offline is difficult or impossible, since most operations require access to the central repository using the internet. But distributed version control systems take a very different approach, because in these systems, every developer has a complete copy of the repository, including the full history of the project. Git is the most well-known example of a distributed version control system. This distributed model has a several major advantages, because developers can work offline, perform commits locally, and experiment freely without affecting others. Because the full history exists in many places, the system is more resilient to a server failure, and performance is also improved, because since many operations are done locally rather than over the network. These advantages are a key reason why the distributed system, especially Git, have become dominant in the open source world. So let's talk about Git and the industry standard. Git was created in 2005 by Linus Torvalds, the creator of the Linux kernel. At the time, existing version control system were not able to handle the scale and complexity of Linux kernel development. Linux designed Git with very specific goals in mind: speed, data integrity, and strong support for non-linear development. One of the most innovative aspects of Git is how it stores data. Instead of recording differences between files, Git stores snapshots of the entire project or at each commit. This might sound inefficient, but Git is highly optimized and only stores the new data when files actually change. As a result, Git is both fast and space efficient. Git's distributed architecture also makes it ideal for open source development. Contributors can clone a repository, experiment freely, and share their change without needing a special permission on a central server. Because of these design choices, Git has become the factor standard version of version control. Today, it is used by almost all major open source projects and by countless companies in the software industry. Now, we see some core concepts and operations, but first, to understand how Git supports collaboration, it's important to understand some of its core concepts. Some as a repository that is the container for a project. It includes all the files and the complete history of changes. When you clone a repository, you get everything you need to work on the project. A commit represents a specific point in time. It is a snapshot of the project that records a set of changes. Good commits are usually small, focused, and well documented with clear messages. Branches are parallel lines of development. They allow developers to work on new features, experiment, or bug fixes without the main version of the project. Branching is one of its most powerful features. Merging is the process of integrating changes from one branch into another. While merging sometimes can cause conflicts, and Git provides tools to manage and resolve them effectively. And remotes are versions of the repository hosted on servers, such as GitHub or GitLab. Developers use push and pull operations to synchronize their local work with these remote repositories. Together, these concepts form the foundation of collaborative development with Git. So, let's talk about the collaborative platforms and pull requests. While Git handles version control, modern collaboration platforms add an additional layer of functionality. Platforms like GitHub, GitLab, and Bitbucket are much more than simple repository hosts. These platforms integrate issue tracking, project management tools, documentation, and automated testing. They provide a shared space where developers can discuss ideas, repair bugs, and coordinate work. One of the most important features of these platforms is the pull request, also known as a merge request. A pull request allows a developer to propose changes to a project instead of directly modifying the main codebase. Contributors submit their changes for review. This review process is crucial for quality control. Maintainers and other contributors can comment on the code, suggest improvements, and identify potential issues. Pull requests also serve as a learning tool, helping new contributors to understand projects and standards and best practices. Now, let's talk about the standard open source workflow. Because most open source projects follow a fairly standard workflow. This process usually begins when a contributor creates a personal fork of the project repository. This fork is a personal copy where they have full control. Next, the contributor creates a new branch for the specific feature or bug fix they want to work on. Changes are made incrementally with small and meaningful commits. Once the work is ready, the contributor pushes the branch to their fork and opens a pull request. This pull request describes the changes and explains what purpose it has. Maintainers then review the proposal changes. They might request modifications, ask questions, or suggest improvements. Once the changes meet the project's standards, they are merged into the main code base. This workflow balances openness with quality control, allowing many people to contribute while maintaining stability and consistency. So, what governance roles and challenge it could have? Because successful open source projects rely not only on technical tools, but also on clear governance structures. Different roles exist within a project, each with specific responsibilities. Contributors submit improvements and new features. Maintainers review and integrate changes. A core team often defines the long-term vision and direction of the project. The broader community provides feedback, testing, and support. Despite these structures, open source projects face many challenges. Technically, merge conflicts, security vulnerabilities, and scalability issues are common. From a human perspective, coordinating across time zones, cultures, and communication styles can be difficult. So, a good governance, clear documentation, and strong community norms are essential to overcoming those challenges. Finally, on conclusion, because in conclusion, version control systems have evolved far beyond simple tools for tracking files. They are now the backbone of global collaborative innovation. By combining powerful technical mechanics with structured social processes, systems like Git enable developers from all over the world to work together effectively. Open source collaboration has shown that large complex software can be built in a decentralized and transparent way. As software continues to shape our world, version controls and collaborative development practices will remain essential. They will continue to evolve, but their core mission will stay the same, making collaboration possible, scalable, and sustainable. Thanks for all